Here's a problem. X plus py equals minus 7. P plus 4 times x minus 4y equals minus 2p. Notice that I have coefficients with the variable p in them for these two linear equations. The first instruction is to find the value of p such that the two lines are parallel. The second instruction is to find the value of p such that the two lines are perpendicular. How to do it? This video looks at a particular problem that was solved to do with setting two lines to be parallel and then setting them to be perpendicular. The lines have variables for the coefficients, and so we need to understand what the relationship is between the x coefficients and the y coefficients in both lines to be able to do that. So before we do that, I had previously made a video about solving simultaneous equations, which I leave the link to down below. But just a little bit of a rehash before we get into this as to how we express in mathematics the equation of a line. The equation of a line is given as follows: y is equal to mx plus b. Now that means that we have the independent variable x and we have the dependent variable y. So whatever x is, y depends on that. So we get a certain value for y from the value of x. And in this case, with that equation, we happen to get a straight line. The m coefficient of the x, that determines the slope of the line. So the greater the absolute value of the m, the more close to being vertical this line will be. The b is the y-intercept, and that tells us where it cuts the y-axis, which is the vertical axis of the two axes on the plane. This is called the slope-intercept form, and it's something we should be familiar with once we're in high school looking at graphing lines. This is as opposed to the standard form given below: ax plus by is equal to c. This is the same thing expressed differently, and just to show that, all we need to do is just make y the subject. So if we bring by to the left hand side, we get by is equal to minus ax plus c. And if we divide through by b to have a coefficient of 1 for y, we get y is equal to minus a on bx plus c over b. So in this case, m is equivalent to minus a over b, and b at the top, small b, lowercase b, is equivalent to plus c over b. Let's now consider what we need to do to make lines parallel. So here's a couple of examples. On the left here I have slope-intercept form. Y is equal to half x plus 2, and below that y is equal to half x minus 3. Both of these lines are in slope-intercept form, and because they are, we can immediately identify that they are parallel, because the coefficient of the x is the same in both cases, 1/2. Both of these lines have positive half gradient, so they go along 2 and up 1 unit. Now, if we rearrange those to standard form, moving across the page, we get multiplying by 1/2, so we get rid of the fraction. For the upper equation, we get 2y equals x plus 4. For the lower equation, we get 2y equals x minus 6. Now, transforming that into the form ax plus by equals c, for the upper equation we get x minus 2y equals minus 4. The lower equation we get x minus 2y equals 6. Now, those two lines are parallel because they're equivalent to the first two lines. How can we tell that now in standard form? Well, if we look at the y coefficient in the upper equation and the x coefficient in the upper equation, if we take the quotient of those, we get minus 2 over 1, which is minus 2. Now if we look at the y coefficient in the lower equation and the x coefficient in the lower equation, and we take the quotient of those, we get minus 2 divided by 1 equals minus 2. So it seems that when we have standard form, if we want a pair of lines to be parallel, we simply need to ensure that the quotient of the y and x coefficients are the same. Let's take another example below, starting on the left with standard form. So the upper equation is 3x plus 6y equals 4. The lower equation is minus 2x minus 4y equals 11. Now it's not immediately apparent whether these are parallel or not, but using the rule that was stated above and applying it here, what do we get? Well, the coefficient of y in the upper equation is 6. The coefficient of x in the upper equation is 3. So the quotient is 6 divided by 3 equals 2. Now the coefficient of y in the lower equation is minus 4, and the coefficient of x in the lower equation is minus 2. So the quotient of those two is minus 4 divided by minus 2 equals 2. Same quotient in the above and below equations. That means they must be parallel. So let's confirm this by transforming these into slope intercept form. So the upper equation becomes 6y equals minus 3x plus 4. The lower equation becomes minus 4y equals 2x plus 11. Now dividing through by 6 in the top case and by minus 4 in the lower case, so we have y as the subject. For the upper equation, we get y equals minus half x plus 2/3. For the lower equation, we get y equals minus half x minus 11 on 4. Lo and behold, we have parallel lines because we have the same coefficient for x. So now we've established the rule for determining parallelism. All we need to do is apply it here. So our first equation is x plus py equals minus 7. Second equation is bracket p plus 4 bracket times x minus 4y equals minus 2p. So let's look at the quotients. On the left hand side equation, the quotient, and we can do this either way, the x coefficient over the y coefficient or the y over the x, so long as we're consistent. So let's do x over y, that's 1 over p, is equal to, from the right hand side equation, we have p plus 4 over minus 4. Now we have two fractions which are equal. Cross multiply. So the denominator of the left multiplied by the numerator of the right. P into p plus 4 equals numerator of the left times denominator of the right. 1 times minus 4, minus 4. So we have p into p plus 4 equals minus 4. Multiplying into the bracket, p squared plus 4p plus 4 equals 0. This is p plus 2 squared. So p must equal minus 2. Substituting for p in these equations with minus 2, we get, on the left hand side, x minus 2y is equal to minus 7. On the right hand side, 2x minus 4y is equal to 4. Now expressing those in terms of y, on the left hand side, y is equal to half x plus 7 on 2. On the right hand side, y is equal to half x minus 1. So we can clearly see in slope intercept form those two lines have the same gradient, therefore they are parallel. So graphing these two lines on a set of axes, we can see, starting with the upper one, y equals half x plus 7 on 2, that these are indeed parallel, the lower line being y equals half x minus 1. The only difference being their separation, as indicated by the y-intercept, where they cut the y-axis. The upper one cutting the y-axis at 7 over 2, the lower one cutting the y-axis at minus 1. Let's start with a couple of vectors aligned exactly with the axes, a horizontal vector and a vertical vector. If we rotate them counterclockwise by an angle theta, so that the horizontal vector is now going through the point 3, 1, and that the vertical vector is now going through the point minus 1, 3. See those 2 points in blue, circled in blue. Now let's have a look at the slope. Before, the horizontal vector had 0 slope. Now it has slope of 1/3 because it goes through the point 3, 1. So it's gone up 1 along 3, slope of 1/3. The vertical vector has now has a negative slope because it's pointing upwards to the left. So that is going through the point minus 1, 3. So the rise is minus 3, or 3, and the run is minus 1. So that has a slope of minus 3. Look what happens when we take the product of those two slopes. Minus 3 times 1/3 is equal to minus 1. This shows us that when we have y is equal to m1 of x plus c, and y is equal to m2 of x plus c, where these two lines are perpendicular, the slopes have a product of minus 1, or m2 is equal to minus 1 over m1. Taking the product of slopes. Going back to an earlier example, y equals half x plus 2. This is in slope intercept form, so immediately we can see the slope of this line is half. In standard form, from the previous slide, or from the earlier slide, we knew that this was x minus 2y equals minus 4. How can we reconstitute the slope from the standard form on the right hand side? Well, if we take the x coefficient, which is 1, and we divide it by the negative of the y coefficient, minus 2, that is 1 divided by negative of minus 2, we get 1/2. So 1 over negative 2 is 1 over 2, which equals 1/2, which is the slope. So the original equation we had to solve was x plus py equals minus 7, and p plus 4 into x minus 4y equals minus 2p. Now, having learnt what we did on the previous slide about the product of slopes of perpendicular lines being negative 1, all we need to do is take the slope of both lines, then take the product of those slopes and set it equal to minus 1. So, taking the x coefficient on the left hand side, 1. Taking the y coefficient on the left hand side, that's p. So going 1 divided by the negative of p, we have 1 over minus p. Now on the right hand side, taking the x coefficient, that's p plus 4, and dividing by the negative of the y coefficient, that's 4. So we have p plus 4 over 4. Now take the product. That means multiply the numerators, multiply the denominators. So we get p plus 4 over minus 4p, and we set that equal to minus 1. Now all we need to do is solve. From the previous slide, we had p plus 4 over minus 4p is equal to minus 1. Now, multiply through by the denominator, minus 4p, and we get on the left-hand side, p plus 4 is equal to, on the right-hand side, minus 4p times minus 1 is 4p. Now, solving for that by subtracting p from both sides, and we get 3p is equal to 4. Dividing through by 3, and we get p is equal to 4 on 3. Now, in the next slide, we're going to substitute that in to the equations we started with. So, having found the value of 4 on 3 for p, we now plug this in to our equations. So we have on the left hand side x plus py is minus 7, which becomes x plus 4 on 3y is equal to minus 7. On the right hand side we have p plus 4 into x minus 4y is equal to minus 2p. When we substitute for p, that becomes 16 on 3x minus 4y is equal to minus 8 on 3. Now, if we rearrange those equations on the left and right into slope intercept form from standard form, for the left hand side we get y is equal to minus 3/4 x minus 21 on 4, and for the right hand side we get y is equal to 4 on 3x plus 2/3. So let's go to the next slide and graph those to confirm that they are indeed perpendicular. Now here's our grid. We'll start by graphing y equals minus 3/4 x minus 21 on 4. That has a negative slope, so it's going down as we move to the right. And because 3/4 is less than 1, it's gradually moving down rather than more aggressively moving down. Now let's impose the other equation onto this grid so we can compare the two. That's y equals 4 on 3x plus 2/3. Notice that that has a positive slope, so it's moving upwards as we go to the right, and 4 on 3 is greater than 1, so it's moving upwards greater than at a 45-degree angle, and they look, and indeed they are, perpendicular, and that can be checked by taking the product of their slopes. Minus 3/4 times 4/3 is -1. These are two perpendicular lines. Thank you very much for watching and listening. Hopefully this was helpful and gives some idea of how this works. Please feel free to subscribe and to like, and more content will be coming soon. Thank you.